So we've gone over a few things that we didn't really describe, and that is we did have a loop condition. If we go back a slide here, you see that the loop condition we have, and we kind of talked a lot about it, was the peanut butter and the jelly. How much do we want? When we put some on there, these are decisions that you are making when you're making a peanut butter sandwich, whether you're conscious of it or not. You're putting it on there. Do I have enough? That is a loop. So here is a fundamental loop condition. Now this structure fits for both the while and the for, although it's missing a piece for the for structure, and that's the incrementation.
But it's basically in that realm.
Yeah, well, you could technically argue that incrementing could fall into process. But so we have an input from the left. If a condition is true, we do a process, and then we go back. We reevaluate. So you can see here visually a while loop evaluates first, processes second, and the second that the condition is not true, we follow the no flow out somewhere else.
Perfect. Similarly, but in reverse, in a do while, we do the process first. So we perform our process, and then we evaluate whether or not to run the process again. So if the condition is met, then we perform the process again. The process will probably be, unless there's an infinite loop, the process will be changing the variables of the condition. Mm-hmm. So once the process changes the parameters of the condition to not be true, then we'll exit the loop and continue to something else in the flow.
A flow chart that moves away from the peanut butter realm, which is delicious, by the way, and moves more into the mathematical realm, could be a power function.
Yep.
Now, this is a very basic power function, so don't you purists say you can't do square roots and blah, blah, blah. Hey, this is for beginners, okay? So you can see that we have our entry point, our input, and then some other conditions here. So the program starts. The first thing that we're going to do is we have our little crooked Saved by the Bell symbol, which is I want the user to actively put this information in. So our program will say, hey, user, give me X and Y. That's what happens here. So the user is going to say, I want X to equal 3, and I want Y to equal 4. So then the next step is data storage. Mm-hmm. Our program has some set values. C, which is just a regular variable, it's going to be short for counter, equals 0. And A, which is short for answer, is going to be set to equal 1. Whereas next we then fall into the loop condition, which Brian will explain.
So now we get into our loop structure. We evaluate a condition, and if the condition is true, we perform an action. And then we do this over and over until the condition is no longer met. So on the top left, we have our inputs, which is x is our base, y is our exponent, and then we have our counter and our answer. Our counter, which is 1, is less than our exponent y. Our counter is 0 when we start, which is less than our exponent y. So we perform an action, which you see next, which is c is equal to 1. Our counter has been incremented. And now our answer is our previous answer, which is 1, times x, which is 3, which is 3. So we now have c is 1 and a is 3. We reevaluate the condition, and 1 is less than 4. We see that the condition is true again. We perform our action again. Now for the second iteration. So we update this again. C now becomes 2 and a becomes y. So now we once again reevaluate that our counter number 2 is less than the exponent y, which is 4. That moves us into our third iteration, which gives us a counter of 3, our third iteration, and an answer so far of 27. Our counter 3 is still less than our exponent, y, which is 4, so we perform it once again. So this is our fourth and final iteration, which we set c to 4, and the answer so far is 81. And when our counter has been incremented to 4, we evaluate for the last time, which now means that 4 is not less than 4. So we exit that.
So that's no longer true.
Correct. So we exit that iteration, and we continue on to our flow, which tells us to print A, or send the output of A
to a screen,
or whatever the case is.
And then end the program from there.
Right. So that takes us to the final terminator.
So I hope that you guys enjoyed this potentially very dry video on flowcharts. But like we said in the beginning, it's important that you at least have exposure.
Right. So this is like a tetanus shot. You just kind of have to do it.
Yep.
You have to go through this. But we're glad that you did. We're glad you made it to the end. And I'm sure you'll find this useful in later videos.
Oh, yeah. And coming up next, leave you on a cliffhanger here. We're going to do something just as boring, but just as important. Pseudocode.